Warm greetings to all. Myself, Dr.D.S.Jayalakshmi, working as an assistant professor in Department of Physics, School of Science and Humanities, Satyabama Institute of Science and Technology, deemed to be University, Chennai. Today, my lecture topic is about Wiedemann Franz law, electrical conductivity derivation part, and the proof of experimental value of Lorentz number by using quantum theory. In our part 1 session, we discussed about thermal conductivity derivation part by using classical as well as quantum approach. So, in this part, we are going to discuss the electrical conductivity derivation by using classical and quantum approach. Then, we are going to derive Wiedemann Franz law. So, by deriving the Wiedemann Franz law, we are getting to know the Lorentz number value. The value of Lorentz number according to the classical theory is 1.12 into 10 to the power minus 8 watt ohm per Kelvin square. The value of Lorentz number by using quantum theory is 2.44 into 10 to the power minus 8 watt ohm per Kelvin square. The experimental proof of Lorentz number gives 2.44 into 10 to the power minus 8 watt ohm per Kelvin square. So, from this it is observed that the quantum theory gives exactly the correct value of Lorentz number as it is agreed well with the experimental value of Lorentz number. In this session, first we are going to concentrate about electrical conductivity derivation part by using classical as well as quantum part. Wiedemann Franz law. It's a ratio between thermal conductivity to the electrical conductivity is directly proportional to the temperature. K is the thermal conductivity, sigma is the electrical conductivity. The proportionality constant is Lorentz number denoted by the letter L and the temperature denoted by the letter T. In this part, we are going to concentrate to derive the value of Lorentz number. So, by using Wiedemann Franz law, how I can derive Lorentz number? So, Lorentz number I can state K by sigma T. From the Wiedemann Franz law, I can state that L is equal to K by sigma T. So, by applying the value of K and sigma, we can calculate Lorentz number. The Lorentz number is deriving by using classical as well as quantum approach. Here, this is the value which is derived from the quantum theory. The experimental value of Lorentz number is 2.44 into 10 to the power minus 8 watt ohm per Kelvin square. The classical theory of Lorentz number is 1.12 into 10 to the power minus 8 watt ohm per Kelvin square. In our first session, as I mentioned, we discussed the thermal conductivity derivation part by using classical as well as quantum theory. By using the classical theory, it is obtained that K is equal to of NV square tau into Kb. By using the quantum theory, it is observed that pi square by 3 n Kb square T tau by m star. Here n is the number of free electrons per unit volume, v is the velocity, tau is the relaxation time, Kb is the Boltzmann constant, then m star is effective mass of an electron. The classical theory is failed to explain the thermal conductivity in terms of effective mass of an electron. In this part, initially we are going to concentrate electrical conductivity derivation by using classical approach and we will do the quantum approach. Electrical conductivity derivation by using the classical approach. So, I will show you the small video which explains how the electron behave with respect to the applied electric field. In absence of electric field, how the electrons are moving. In presence of electric field, how the electrons are moving. This explains the part of electrical conductivity of electrons by using Drude and Lorentz theory. Here, first we are considering a rod which has many number of free electrons. In absence of field, the free electrons are moving randomly. In absence of energy, in absence of external electric field, the electrons are moving randomly. When in presence of field, now we switched on the circuit. In presence of field, how the electrons are moving? All the electrons are moving in a uniform direction. All the electrons are moving in a uniform direction which is opposite to the field direction. The field is coming from this direction, the electrons are moving opposite direction to the applied field direction. This is what the electrons behavior in presence of electric field. Based on this electric field, we are going to derive the electrical conductivity nature of an electron. We are going to start the expression of electrical conductivity. So, as we mentioned, we taken the rod. In a rod, many number of free electrons are there. In the application of external field, the electrons are moving in a uniform direction which is opposite to the applied field direction. Based on this phenomenon, we are going to derive electrical conductivity. What is electrical conductivity? Electrical conductivity is the ratio between the electrical current density per unit applied electric field. The electrical conductivity is defined as rate of charge flow across unit area in a conductor per unit potential gradient. The electrical conductivity is defined the ratio between current density to the applied electric field. So, we can state sigma is equal to J by E, its unit is mho per meter. First, we are going to concentrate to derive electrical conductivity sigma by means of classical approach. So, for that we are considering the rod is in presence of external electric field. So, the electrons are subjected to electrical conductivity. So, the electrical conductivity we can able to derive by using current density J and electric field E. So, what is current density? It is about NeVd. So, E is the charge of an electron, so that I represent here the negative sign. Vd is drift velocity. What is drift velocity? The change in velocity of an electron with respect to the applied electric field. In this scenario, we are going to derive electrical conductivity in presence of electric field. So, due to the applied electric field, the electrons undergone change in velocity. This is what termed as drift velocity, denoted by the letter V in suffix T. So, N is the number of free electrons, E is the charge of an electron, so that representing the negative sign. Vd is the drift velocity of the electron. So, as I said, drift velocity is nothing but the average velocity attained by charged particles due to an applied electric field. Drift velocity, we can state it as product of acceleration into time. What is acceleration? Acceleration is the rate of change in velocity per unit time. Now, we consider a rod is subjected to applied electric field. So, the electrons are undergone the electric field. So, the changes in forces are exist in the cloud of electron due to the applied electric field. So, that I can state each electron experiencing applied electric field. So, the force experienced by the electron can be termed as minus E into E. Minus, here we are representing the charge of an electron. Generally, how we can define force according to Newton's second law of motion? F is equal to ma. This is what the general expression for force. In our criteria, F, the force experienced by an electron, is minus EE. According to Newton's law, F is equal to ma. Equation 3, equation 4 both gives the expression of force. So, now we are going to equate both. When we are equating minus EE is equal to ma, we are going to derive A, the expression of acceleration. So, the expression of acceleration we can get minus EE by m. So, this is what we are considering equation number 5. So, already what we mentioned that drift velocity is nothing but product of acceleration and time. Here in equation 5, we derived the term of acceleration is nothing but minus EE by m. Minus E is the charge of an electron, capital E is applied electric field, m is the mass of an electron. So, now substitute 5 in equation 2. By substituting acceleration term in equation 2, it means drift velocity expression, we are getting the final drift velocity is, instead of A, we are substituting equation 5. So, minus EE by m into tau. This is the obtained expression of drift velocity by using acceleration. This acceleration we derived by the application of electric field when the electrons are subjected to the applied external electric field. So, equation 6 gives the modified expression of drift velocity. Now, the drift velocity expression, now we are going to substitute in our equation 1. Initially, we derived the expression for current density. Why we need current density? Because if we have current density, then only we can derive electrical conductivity. Because we know that electrical conductivity sigma is equal to J by E. So, that we are in need of J. So, to derive J, we are in need of drift velocity because in equation 1 it is given as J is equal to minus NeVd. From the equation 6, drift velocity is derived as minus EE by m into tau. So, now we are going to substitute equation 6 in 1. So, J is equal to minus N E into Vd. Vd is equation 6 minus EE by m into tau. So, that minus minus getting plus, minus representing charge of an electron. So, that N E square capital E tau by m. This is the modified current density by substituting the drift velocity term. So, the final expression of J is N E square into capital E tau by m. This is the equation we consider as number 7. According to the basic definition, initially we discussed that electrical conductivity is equal to J by E. Now, in equation 7, we derived J, current density. Actually, from the basic definition sigma J by E, we can rewrite it as J is equal to sigma E. So, J we can derive by using the equation 7. From the equation 7, J is equal to N E square capital E tau by m. So, now we are going to equate both. This is the equation 7 we derived from our experiment. J is equal to sigma E derived from the basic definition of electrical conductivity. Now, we are going to equate equation 7 and our basic definition. So, when we are equating N E square capital E tau by m is equal to sigma into E, because here current density always directly proportional to the applied electric field. As a proportionality constant, we used electrical conductivity term sigma. So, by equating J with sigma E, E are cancelled. Here the capital E represents applied electric field. So, we are getting that Ne square tau by m is equal to sigma. See, we obtained the expression of electrical conductivity. This is what, according to the classical approach, the final expression of electrical conductivity. The expression of electrical conductivity is sigma is equal to Ne square tau by m. N is the number of free electrons per unit volume. E square, so that we are not representing negative sign, because minus E into minus E, it becomes E square. Tau is the relaxation time. So, relaxation time is nothing but the average time taken between two successive collisions of an electrons. This is what relaxation time tau by m. M is the mass of an electron. So, the obtained expression of sigma is Ne square tau by m, given number as 8. This is the expression derived by using classical approach. Now, how we can modify the same equation by using quantum approach? So, as we already aware that in quantum approach, instead of normal mass of an electron, they are considering effective mass of an electron. What is the effective mass of an electron? The change in mass of an electron when the electron is subjected to applied electrical field or any collision or any external force. So, equation 8, according to the quantum theory, by using effective mass of an electron, it is reframed as sigma is equal to Ne square tau by m star. M star is, as I said, effective mass of an electron, a particle's effective mass or change in mass in presence of external applied electric field. So, the final expression obtained from classical theory of electrical conductivity is Ne square tau by m. The final expression of electrical conductivity by using quantum approach is Ne square tau by m star. So, now what we are going to do by using the classical electrical conductivity derivation and quantum electrical conductivity derivation? We are going to find out Lorentz number. These are all the expressions so far we derived. In our part 1 session, we derived thermal conductivity expression by means of classical approach as well as quantum approach. By using classical approach, the thermal conductivity K expressed as of Nv square tau into Kb. By using quantum approach, the thermal conductivity K is expressed as pi square by 3 into n kb square T tau by m star. Coming to the part of electrical conductivity. By using the classical approach, sigma electrical conductivity can be expressed as Ne square tau by m. By using quantum theory, sigma can be expressed as Ne square tau by m star. We want to notice here the quantum approach alone considered the effective mass of an electron. The classical theories failed to consider the effective mass of an electron. It means how the electrons undergone the change in mass with respect to the applied electric field or applied any external force or by means of electron-electron collision, how the change in mass occurs. This is failed to consider in classical theory. Now, we are going to prove Lorentz number value. To prove the Lorentz number value, as we discussed from the Wiedemann Franz law, K by sigma is equal to LT. So, as I already mentioned that L we can calculate it by K by sigma T. Now, we have the expression of K and we have the expression of sigma by using classical approach and quantum approach. By using all these expressions, now we are proceeding further to calculate Lorentz number value. First, we are initiating with classical approach. According to the classical approach, the expression of K in our part 1 session we derived, it is about of NV square tau into Kb. The expression of sigma is Ne square tau by m. We need to calculate L. How I can calculate L? K by sigma T. This is what we are going to do. K by sigma by using these two expressions of NV square tau Kb in numerator, Ne square tau by m in denominator. So, what I can do? N are cancelled. Then tau are cancelled. Then m in denominator moves to the numerator. So, the final expression I can write K by sigma is equal to mv square Kb divided by 2e square. M is the mass of an electron, b is the velocity of an electron, Kb is the Boltzmann constant, E is the charge of an electron. By using classical approach, the ratio of K by sigma is mv square Kb divided by 2e square. According to the classical free electron theory and kinetic theory of gases. So, in our part 1 itself we discussed that of mv square we can be equated as 3 by 2 kBT. Kb is the Boltzmann constant, T is the corresponding temperature. In our ratio of K by sigma, how we can correlated the kinetic theory of gases? See, we can take this of mv square. So, of mv square we can be equated as 3 by 2 kBT. So, I am substituting this term in our K by sigma ratio, then it will give 3 kBT into Kb divided by 2e square. So, K by sigma by using classical free electron theory concept, it means of mv square is equal to 3 by 2 kBT. By using this concept, classical free electron theory approach, we are rewritten as K by sigma is equal to 3 Kb square T by 2e square. So, K by sigma is equal to 3 Kb square by 2e square into T. I can rewrite the same expression as equation A. Now, we can take the general basic definition. K by sigma is equal to LT. Consider as equation B. Compare A and B. While comparing A and B, what we are getting? L is equal to 3 Kb square by 2e square. By comparing the classical approach ratio of K by sigma with the Wiedemann Franz law, we obtained that L gives 3 Kb square 2e square. L is equal to 3 Kb square 2e square. Kb is the Boltzmann constant. The value of Boltzmann constant is 1.38 into 10 to the power minus 23 joule per Kelvin. Then the charge of an electron is 1.6 into 10 to the power minus 19 coulomb. By substituting all these constant values in the Lorentz number expression, 3 kb square by 2e square, 3 instead of kb substituting 1.38 into 10 to the power minus 23 the whole square, 2 into e square. Instead of e square substituting 1.6 into 10 to the power minus 19 the whole square. We are getting the value as 1.12 into 10 to the power minus 8 watt ohm per Kelvin square. This is the value of Lorentz number by using classical approach. As we discussed initially, the experimental value of Lorentz number is 2.44 into 10 to the power minus 8 watt ohm per Kelvin square. But when we compared our classical approach Lorentz value with the experimental value means it is not agreed well. So, our observation is classical theory is not proved the experimental value of Lorentz number. It is failed to reproduce the experimental value of Lorentz number. The reason is the classical theory is not consider the effective mass of an electron. The experimental value of Lorentz number is 2.44 into 10 to the power minus 8 watt ohm per Kelvin square. Then classical theory is failed to give the experimental value of Lorentz number. Then how I can get the experimental value of Lorentz number? So that we have chosen quantum theory. By using quantum approach, already we derived the expression of K sigma. As we discussed Wiedemann Franz law, K by sigma is equal to L into T. According to the quantum approach, we already derived the expression of thermal conductivity K, the electrical conductivity sigma. The expressions are K is pi square by 3 into n kb square T into tau by m star. Sigma is Ne square tau by m star. Here the parameters n is the number of free electrons per unit volume, kb is the Boltzmann constant, T is the temperature, tau is the relaxation time, m star is the effective mass of an electron. Here in expression of electrical conductivity, n is the number of free electrons per unit volume, E is the charge of an electron, tau is the relaxation time, as m star is effective mass of an electron. So, according to the quantum theory, in the expression of K as well as in the expression of sigma, we considered the effective mass of an electron m star. By using these expressions, now we are going to get the value of Lorentz number. How to get the Lorentz number value? We want to get the ratio of K by sigma. So, by using these expressions, we are getting the ratio of K by sigma is pi square by 3 n kb square T into tau by m star divided by Ne square tau by m star. In both the terms, n is common. So, n cancelled. Then, when we look into the relaxation time, tau also common. So, both the tau are cancelled. Then, m star effective mass of an electron. Already I mentioned that both the expressions we derived in term of effective mass of an electron. So, effective mass also common term in the expression of K and in sigma. So, m star also cancelled. Now, we can finally obtain K by sigma is pi square by 3 into kb by E the whole square into T. This is the ratio of K by sigma obtained by the expression of K and sigma which are derived by using quantum theory. Now, this ratio we can compare it with the Wiedemann Franz law. Then, the Lorentz number we can get pi square by 3 into kb by E the whole square. This is the expression K by sigma, the ratio of K and sigma by using quantum approach. K by sigma is equal to LT is the basic definition. Now, compare A and B. By comparing A and B, it gives pi square by 3 into kb by E the whole square is the Lorentz number expression by using quantum approach. So, now we are going to calculate the value of Lorentz number. By substituting all this value, pi is 3.14. Already we know that kb is the Boltzmann constant. The value is 1.38 into 10 to the power minus 23 joule per Kelvin. E is the charge of an electron. The value is 1.6 into 10 to the power minus 19 coulomb. By substituting these values, pi square by 3, kb and E value, we are getting the Lorentz number is 2.44 into 10 to the power minus 8 watt ohm per Kelvin square. So, the experimental value of Lorentz number is achieved by using the quantum approach. So, that we are saying that the quantum theory is a successful theory. As I mentioned, the experimental value of Lorentz number 2.44 into 10 to the power minus 8 watt ohm per Kelvin square can be achieved by using the quantum approach. Here our observation is the experimental value of Lorentz number is agreed well with the Lorentz number value which is derived by using quantum theory. So that we are stated the quantum theory is a successful theory than classical theory. Thank you to all.